Okay, dear colleagues, it's 3 minutes past 11. I think we have to start our session. So I welcome you to the last day of the conference. And this day is starting with the keynote talk given by Andrew Chopin and from Australia. And it's my great pleasure to introduce our keynote speaker today. So Andrew is a professor in computer science at the University of Melbourne, and his research interests are based on applications of algorithmic efficiency to problems such as data compression, text search, analytics of political texts, and so on. And for the last 25 years, he has been charged with establishing the Melbourne Analytics Platform, which is also the topic of this keynote talk. And this platform is a group of academics who specialize in supporting research of others with cutting-edge data, analytics, and computational techniques. Prior to working at Melbourne, Andrew worked at RMIT University at Melbourne, Curtin University at Perth, and Oregon Health and Science University at Portland, United States. Okay, so Andrew, I suppose the floor is yours. Please start your talk.
Thanks, Sergey. And maybe Victor, if you can.
Sorry.
Just getting some. Yeah. So, hi everybody. Yes, chatting about the Melbourne Data Analytics Platform. So this very long and sort of cumbersome title here, developing a workforce to support research reliant on data and compute. So why didn't I just write e-research, which is the standard topic, the standard term for talking about a group of people that support research using digital methods, using high performance computing, using software. So it was deliberate, and I'll explain why in a minute. This talk I'm giving today has been also worked on with Paul Gruber, who's my colleague at Melbourne. So just before I explain why I didn't use the term e-research, for those of you who want to skip to the end, you don't like my accent already, the Melbourne Data Analytics Platform is at this URL down the bottom here, so which maybe I'm in front of. Nope. I'll zoom out of the way. So if you want a spoiler alert, you can skip straight to the end. So Melbourne University, for those of you who don't know, we have old buildings, we have new buildings, we have ugly buildings. So it's a typical university, I think, in that sense. We like to talk about rankings, except when we're not number one. We don't like to talk about them anymore. We're quite a large university, 69,000 students, a couple of $1 billion budget. We were 40% international students until the Australian government decided to close the borders to keep COVID out, but hopefully that will return. In terms of research, we're a research intensive university, 4,000 researchers, 5,000 PhD students, millions of dollars floating around. So just to give you a flavour for Melbourne University, if you're not familiar, we're kind of an old, by Australian standards, university, so over 150 years old and research intensive. And we've got 10 faculties, really. I'm going to turn my video off here. I think it's getting in the way. So 10 faculties. We have the Faculty of Medicine, which is bigger than most many US universities, the Faculty of Science, these boxes here, 10 boxes, are in size to the research output of our various faculties. So if we were to build, coming back to this term e-research, so software, hardware, computing support for research, if we were to build a typical e-research service for all of these faculties, who would use it is the question. And so I would conjecture that this would roughly be the use. The Faculty of Science would make heavy use of an e-research service. Engineering, half of them would use the service and half of them would do their own thing. There'd be some bioinformatics in medicine and in veterinary sciences. There's some engineering types in architecture who might use it, but we've got all of the humanities and the social science who probably wouldn't make use of a central e-research service. And so what we wanted to avoid this, right? We want humanities and social science obviously use digital methods, and the data sets are increasing as data is linked from various platforms and scraped from Twitter and Facebook and all of these sources. Digital humanities is very much of importance. So we didn't want to construct a service that would ignore half the university, or a third of the university at least. What we really wanted was, in addition to the computational expertise and the hardware, etc., we wanted navigators, translators, and educators in addition to the computing services. So in particular, looking first at the navigators, we've got this helpful person here who can see through the maze and can guide researchers. Those of you who are in computing and wouldn't perhaps appreciate this. Those who aren't know exactly what I'm talking about, perhaps, when people talk about instances and virtual machines and cores and GPU. It's a maze of choices. Where do I put my data? How do I keep it private? All of these things. So all of these capabilities exist around the university in one way or another, whether they be as a central service or even with other research groups. But we need someone who can direct traffic and can interpret. When someone comes along and says, I need machine learning, you need to say, okay, well, do you just need linear regression, in which case go to the statistics department? Do you need an off-the-shelf a deep learning model, in which case you can go to the software engineering platform and they can implement that for you? Or do you really need something more sophisticated, in which case you could engage with the Centre for Data Science? So this kind of navigating all the possibilities is something that we need at the university. In addition, the central panel here, we need translators. So we need translators between disciplines. So if we were looking at a collaborative project between the law faculty and science on the ethics of AI, we've got two different languages going on already, and throw into the mix there, we want to do some agent-based simulation, and you've got a third language as well. So we also need people who can translate between disciplines and translate between computing jargon as well. And so depending on your background, you could decide which of these people you are. If you're the spiral, well-ordered mind, talking to the spaghetti brain, or vice versa. And of course, it depends. I'm sure all of you think you're the well-ordered spiral brain, and then the other is the spaghetti brain. So if someone comes along and says, I need a cultural repository, how do we translate that into a web page with an underlying database, or a secure cloud instance, or whatever it may be? And then finally, in addition to navigators and translators, we also need educators. And you've got Donald Rumsfeld here, who had this famous sort of quote about the known knowns, the known unknowns, and the unknown unknowns. So there's the known knowns. So if you know what machine learning is and you know that you use it, then great. You can probably find someone to implement it, or you could implement it yourself. There's the known unknowns. So you know that machine learning exists, but you've got no idea what it is, but you know that it's out there somewhere. And then, of course, there's the unknown unknowns. And this is the group that we really want to try and cater for somehow, but it's very difficult. So the digital humanities is one particular area where this is quite prevalent. We know that people are using very inefficient hand coding of text, thematic analysis, sometimes which is very justified. A lot of the data requires human intervention and human interpretation, but other times some of the processes could be automated, and larger data sets could be collected, stored, and processed. Similarly, over in sciences and engineering, when you've grown up with perhaps a numeric tradition, you might not be aware of many of the natural language processing and text algorithms and techniques that exist. So we want to be able to help people find the right service. We want to be able to translate their needs into something that computing people can understand and then can deliver on. And we also want the ability to help people imagine what they could do that they don't know about, their unknown unknowns. So these three typical sort of e-research units have elements of these, but often the staff working there are hardcore computer people, right? They're DevOps, they're sysadmins, they're software engineers. They might be able to do these things as a hobby, but they haven't been trained or perhaps aren't naturally inclined to do these kind of things. So if we want to build this workforce that's got all these technical skills, but also has translators and connectors, and I'm sort of leaving the educators aside for the moment, they're a bit hard. So the challenge then is, how do we establish this technically capable workforce that has translators and connectors? And really it comes down to, or as we found over the years and in the literature, it comes down to recognition. So recognition at several levels, recognition at a personal level for those involved. They want to be recognised and rewarded. And that's what's talked about on this slide. I'll go into that in a minute. But also recognition from people with the money, right? So someone has to pay this workforce. So we want them to be valued not only by researchers and colleagues and peers, but by people with the purse strings, people who are going to pay. So we know e-research has a strong sort of a tradition. We know that you can employ computer people, you can count things like user satisfaction, projects completed, number of systems produced, whether they be open source, whether they be in-house, how systems are maintained, uptime, you know, all of these things we can count, and it's kind of well established what you expect from an e-research unit. And along with that, there's people get paid, there's performance bonuses, there's promotions, and there's a career path. You can make a career as an e-research practitioner. The other main group at the university, of course, is the academics. And that's a very well established, a very old tradition of what's valued and what's recognised. So in particular, peer esteem or peer prestige, peer review. And the more modern, it's called impact, but of course, academics have been trying to have impact for many, many years and just haven't been calling it impact, perhaps. So there's a well-established promotion pathway, career path. There's, you know, awards, rewards for academics. So both those communities are quite well established. Navigators and translators, on the other hand, don't have a traditional recognition framework. So if your job is to connect people so that they get to work on new research projects, or to guide people to a different service that you don't provide, suddenly it's hard, it's more difficult to count and recognise these as valuable activities. It's not core business, if you like, particularly at the university, right? It's not teaching students and it's not producing research outputs or research impact directly. So there's no established career path for these people. So this is the challenge. How do we create a career path for people with these skills? And just as an aside, I'm not including references in these slides, but in the actual printed abstract, there's some references to the literature on this kind of thing as well. In particular, there's some work around a thing called the third space that sits between academia and services. Some quite good work by Celia Whitchurch out of England, and there's some interesting stuff from Canada too, mainly in the health, looking at the difference between nurses and doctors. But it's a very similar kind of idea. So who are these people I'm talking about that I want to offer a career path for? And again, there's papers and just tables and descriptions of attributes these people should have, but this is what we think and what we've distilled. So of course we want them to be very smart. It's at the university. You know, those of you who are academics, or those of you who deal with academics, which maybe most of you know, that academics don't tolerate fools very easily. They have not much time for people who aren't very sharp and on the ball. So we need smart people. We need them to understand research because we want them to support research. So they have to know what drives researchers, what's important to them, these sorts of things. They need to be very flexible. So again, going back, we have 10 faculties and we want to support all 10 faculties. So one month they could be working in arts, next month they could be working in physics, the month after that they could be working in the vet department. So they need to be very flexible. And of course, along with that comes risk. So it's not unlike perhaps a software engineering role or a sysadmin kind of role, where it's a very clear expectations and quite low risk, right? If you do the role that you're described, then you'll be fine. This workforce is going to have a degree of risk associated with it because there aren't those traditional recognition and reward frameworks, and because you'll be encountering lots of different things across lots of different disciplines. It goes without saying, I guess, that translators and navigators have to be good communicators. And the final point here, which is hard to recruit or spot, but it's to do with ego, right? So these people are going to be supporting research, not necessarily leading research. And that requires a different outlook, perhaps, on research. If you want to be a successful professor, an international expert in your field, dominating the room with your keynote speech, like me. No, I can't even see you all, so you might not even be there as far as I know. But anyway, you have to sort of leave your ego at the door in a way. You have to be prepared to support research and play a supporting role. So if we can find these magic people, and for those of you who've skipped ahead to the MDAT website, you can go and watch videos and read stories about the people that we have employed. What can we offer them? We can't offer them large sums of money, right? Because we're a university. And industry can. So you've got your consulting firms and your insurance companies and your banks and large tech companies who can offer triple, quadruple the salary that we can offer at the university. So we have to offer them something else. We can offer them very interesting challenges and problems. We can offer them variety, we can offer them collegiality, and hopefully we can offer them a career path. So we've got an idea of the type of people we want. We know that we need to reward and recognise them. The question is, how do we go about this? And so fortunately, the University of Melbourne had a category of academic employment called academic specialists. And this was originally designed for people who wanted to focus on teaching. So you could be a teaching specialist and not do any research, basically. But we thought, okay, maybe we can sort of subvert or borrow this process a little bit. And instead of having someone specialize, an academic specialize in teaching, perhaps they can specialize in research support. And just a little side note here, we sort of chose this route. We had an opportunity to be disruptors, I guess, to try something, you know, really crazy, but we didn't do that. And there's literature on this as well, which I refer to in the paper. Systems in the university, while they're very cumbersome and bureaucratic, and of course for any large institution, and that's the way things turn out. But also, some of them are there for very good reason, right? To ensure equity, to ensure transparency, to ensure compliance with the law, etc., etc. So we didn't want to be cowboys in some sense. We didn't want to go crazy and sort of a startup mentality. We wanted to try and slot into the existing structures if we could, and it turned out we could. And so these specialists will be recognised for collaborating with researchers, connecting researchers across disciplines, increasing the impact of research, knowledge transfer and upskilling of researchers, and this is where the education part comes in, right? So we've got translators, navigators, but educators as well. In addition to helping researchers directly, whether it's creating a web page, creating a database, implementing some machine learning, doing some computer vision, whatever it is that we do, we want to also leave some skills behind. We don't want to have to provide ongoing support. We want to teach the researchers to fish, I guess, so they can catch their own fish. And in particular, we wanted to avoid becoming a service provider, which, again, coming back to the e-research kind of ideal, e-research is often, e-research units, and the ones we looked at in Australia and even overseas were constructed as service providers, right? There was a list of services that they offered, and you could engage with them for those services. We really wanted to build this as a collaborative academic enterprise. So our staff are not only are they technical experts, but they're active collaborators in the research. They're not just delivering a service, they're looking for new ideas, generating research ideas, steering the research in different directions. So very active collaboration. And I said an educator idea. We deliberately tried to avoid being a training organisation. So there's a couple of reasons for that. One, delivering training is very easy in some sense, right? You see a group of, you go over to the fine arts department and you see that they're keeping their videos metadata in Excel, and you kind of tear your hair out going, oh, that's terrible, let me teach you in Vivo or Omica or whatever fancy tool is around, and you teach them the tool. You walk away, and of course within a couple of weeks they've forgotten it because they're not using it regularly. So training is a quick sugar hit, but we didn't see it as a long-term investment in sort of general upskilling and knowledge transfer. The other sort of, and just as a pure tactic, training is one of the first things to get cut, right? When there's budget cuts, look around and you cut the training. So we just as a tactic as well, we didn't want to align ourselves with as a training deliverer. What does this mean in practice for these staff? So they're employed as academics, they're expected to support research but not lead it, and they're expected to do this other translation, navigation, and community building. So what are we looking for? We're looking for co-authorship of papers, but not necessarily first authorship. And maybe even just an acknowledgement, maybe not even authorship, but some mention in papers that are produced from research groups that we help. Perhaps they're named as investigators on grant applications. Perhaps they're just mentioned in the body of the grant as someone who might help. or perhaps they just help write the grant and they don't even get a mention. They could co-supervise students, and that is a traditional academic kind of well understood form of recognition. We'd be looking for testimonials from the researchers that we partner with, so some qualitative evidence that we're being useful. And just as an aside, I've got down the bottom here, for those of you unaware of the San Francisco Declaration on Research Assessment, the university has signed up to this DORA Accord, which means we don't go for research metrics out of context. So we're not interested in journal impact factors at all. We're not interested in sort of the venues in which things are published. We're interested in science on its own merit. And that's a bit of a culture shift in some disciplines at the university. And finally, these are academics, so perhaps they can, and as a teaching and research academic or a research academic, you try to build your brand, you attend conferences, you network, you publish papers in certain venues and try and position yourself as an expert in your discipline. And perhaps they can do that as well. They can position themselves as experts in research support rather across many disciplines. So that was our plan. That was what we wanted, our end state. We want a group of academics, technically competent, can translate, can navigate. They're sort of super beings, but somehow we're going to recognise them and offer them a career path. How did we go about it? Well, first we had to convince the deans and the vice-chancellors and the like that they should pay for this. And so this is where words like unique, innovative, visionary, all these kind of things, right? The types of things you write in your grant applications. And but in Australia, and in fact, we haven't found a group like this worldwide yet. And I'd be interested if any of you know of one. So there's a lot of e-research groups. Most universities have a group that does support digital methods for research, but very few of them are academic. Most of them are professional staff or service staff, and very few of them, I hope one day our staff will get promoted to a professor of data specialism, and that remains to be seen. We'll see how we go. So anyway, it's unique, leading, innovative, visionary, all those types of words that deans and funders like, and practically it provides economy of scale, right? You get, rather than having each individual research group and each individual faculty running their own cloud, running their own cluster, running their own software engineering group, running their own machine learning group, we'll centralize it and we get economies of scale and scope. The deans bought it, which was great, and they provided us with some funding. So in phase one, we recruited 5 to 10 people internal to the university. And the key to this was it brought the navigators came already knowing the landscape. We didn't have to teach them about the university. And also they could hit the ground running. They already had some networks with researchers, and so we could stand up some projects straight away. We gave them a lot of agency. So again, one part of being an academic is academic freedom. So you're free to choose what you work on. And so within constraints, that's also true of our team. So that again distinguishes it from a service provision. If someone comes along with a project that nobody wants to help with, then the person doesn't get help within reason. There's obviously some limits to that. And it's run by an academic director, which is myself for the last few years. So that was phase one. And then phase two, once this group was established, and that was in early 2019, we gave them a 9 to 10 months to get established. We then recruited externally to bring in new people with different research backgrounds, different skills, and we added a manager role because we got up to roughly 20 people, and I was starting to lose control. And then finally, once we've got all these people together, they're operating, the challenge then is to stabilise the fundings and prove our worth. And we'd hoped that that would have been done by now, but of course COVID came along and disrupted the university budget and disrupted all our lives. So hopefully by the end of next year, we'll have stabilised our funding. So the next series of slides is the way the data analytics, so this group, the Melbourne Data Analytics Platform, has now existed for 3 years. I think it's been very successful. The next series of slides is the slides is how they describe themselves, if you like. So when they go out and present at different places around the university. So emphasize collaboration, right? Not a service provision, but we'll work next to you and help you with your research. And we know about computing and we know about digital methods. Got about 20 or so people, very amazing variety of backgrounds. We've got people with PhDs in archaeology, music, geography, computer science, biology, computational biology, actuarial science, physics, all sorts of stuff. They're not all physicists, and that's another feature of many e-research teams is they tend to be a lot of physicists for some reason. The way we work, we call for collaborations at the beginning of every year or twice a year for 3 to 6 months. So it's a competitive process. People apply to work with us, outlining what their data is, what their computation needs are, what their algorithmic needs are. And the team chooses all the projects they like. And then we also have an external panel of senior academics to rank the results. It's mainly teamwork. Like I say, there's a lot of domain expertise in addition to technical expertise. So if there's an arts project that needs some mapping, well, we call in the geography guy, and we call in the arts guy, and we call in the, I'm using guy as a gender non-specific here. And so we work in teams, and we try and leave behind some skills after the 3 to 6 month project has ended. What do these people actually do on the ground? Write software, pipelines, workflows, co-author papers, contribute to research grants, get people onto cloud, get people onto the HPC. That might help them use AWS, Amazon. We might help them use the local cloud. All sorts of stuff. Teach them Git. And for those of you who've ever battled Git, you'll know that that's definitely a valuable. Having someone help you through that process is very helpful. In addition to technical stuff, there's also a section, and those of you in the humanities and social sciences in particular know, well, actually, that's not true. Even medical researchers or even social scientists in particular, when you're dealing with sensitive data or privacy, there's a lot of extra stuff that has to go along other than where to put the data and how to crunch the numbers. So we also have data stewardship expertise, help people design governance processes for looking after their data, how to write metadata and design metadata, how to visualize their data at the end. And the final aspect here is community building. So because we help people navigate, because we help them translate, we build up a lot of relationships across the university. And so we want to leverage that network to help connect people with each other and help them support each other. What have we learned? And this is the staff from the platform themselves speaking here. I've learned some different things, which I'll talk about in a minute. Collaborate early, don't do last minute scrambling. Make sure collaborators have time to engage. We've come, academics are very busy people, and they say, oh, here's someone who can do some data science for me. Let's hope they do it. I'll come back in a month. Doesn't work so well. Make sure, as with all research projects, you talk about authorship and recognition up front. Make sure you're meeting people where they are, as in in their home discipline. Don't try and drag them off into computing land or force them to use Git when they don't really need to, for example. And of course, do our translation and communicate. What have I learned in this process? So, full support of the senior leadership has been essential, right? Particularly as COVID has hit and the university budget has taken a downturn. The senior leadership of the university has had to make some hard choices, right? We have to cut staff and we have to not fund a lot of the extra research that we were doing. And so we were fortunate to survive those cuts and have the support of the senior members of the university who saw that this offering a career path in this kind of work, in this research support, is going to lead to something very valuable and quite unique in Australia and possibly the world. There was the existence of the academic specialist classification allowed us to take this particular approach. And so that was a policy/legislative structure within the university, which was quite handy. The two-phase approaches worked well. So internal recruitment first to bring in the networks and existing navigation abilities, and then bring in external people later. Of course, careful selection of staff is crucial. I mean, that's true of any undertaking, right? But those attributes that I listed earlier, the ability to embrace risk and be very flexible, is very key to this kind of, because we're new, we're trying to establish a career path and recognition. You need that flexibility and the risk. We've had some excellent academic mentors. So Paul Gruber, my co-author, has been one, and we've had some others across the university who've been very supportive and have helped the staff. And of course, results are essential. Warning, here's some metrics that I try and avoid, some descriptive statistics out of context, that there's now over, in fact, this is an old number, so there's now over 150 researchers at the university who we've collaborated with, all of who would advocate for us. We've had 5 new grants that have been awarded based on our input. We've had at least 12, probably more now, closer to 20 papers co-authored. We've had lots of testimonials of the type, this research could not have been done without MDAP support. We've also had 5 people promoted. So through the normal academic promotions process of the university, these people have been promoted, not for having led any research themselves, right, as supporters of research. So that's very exciting, and again, sort of signals we're on the right track. All this, you know, I'm painting quite a rosy picture here, but of course, part of this high risk, highly flexible environment applies to the entire undertaking in a way. We still haven't solved this problem of the unknown unknowns. So how do we help in the humanities in particular, but also clinical scientists who just don't know about the existence of many digital methods? And of course, you can't just go and say, oh, machine learning exists, you should use it. You have to try and somehow put it in their context and take them on a journey to realise that these digital methods exist. Another thing that we haven't quite solved is the balance between the MDAP staff are academics, right? Some of them are quite fresh out of their PhD, just graduated, in fact graduated while working for us. And so they have their traditional academic pathway is still open to them. So we have to balance that. We have to sort of allow them, don't want to shut the door on their academic career by saying they can't pursue their own independent research. But of course, they're being paid to do the research of others. So that's a delicate balancing act. We've had central support to date, but we need to move more towards a user pays model. And again, how we do that, how we do that in an equitable way. So we don't want only the people with large research grants to get our services. We want to bring the whole university up with us. And finally, and this is more recently, we've been trying to work out how to fight the pressure to oversimplify this sort of quite complex activity. So in particular, we're trying to avoid the use of SMART goals. So those of you who don't know, SMART goals are goals that are specific, measurable, attainable, relevant, and time-based. And this is a very big trend in project management, and has been for years. And it makes sense, right? If there are clear deliverables, a small number of actors, clear organisational relationships, and it's a simple project, then SMART goals make sense. But we're not a simple undertaking, right? We're a team of academics forming many relationships across many different disciplines, and that leads to emergent behaviour. So those of you who know your complex systems theory will recognise many of these words, right? High number of actors, high number, if you're thinking about graph theory, high number of nodes, high number of edges, emergent behaviours. So in this environment, you don't want to be applying metrics. We don't have targets like each of our MDAP staff should be co-author on 3 papers. That drives perverse behaviour, and you get people scrambling to get co-authorship, but not fulfilling their role. I think, is that the hurry up there from, did you put your hand up there, Sergey? Maybe I should finish. So in order...
No, it's just an accident. So please, we'll have enough time actually.
Okay, good. I'm nearly finished anyway. So,
okay.
So in order to avoid this sort of trap of bean counting or smart trivializing or oversimplifying what we're doing, the approach that we're working with, and we haven't quite got here yet, but we're using it, and I think it's starting to work, and it's described a little bit more in the paper, is that rather than these numbers, we're trying to work towards claims, and we're measuring how mature our claims are. So here's our 3 main claims. So one around support, staff will do this. One around communities, we're building communities, and the other about visibility. And we routinely, every 6 months or so, we sit down together and try and work out what evidence we have. We might have some quantitative evidence, we might have some qualitative evidence, and we try and rate, are these claims weak, medium, or strong? How mature are the claims, if you like? Those of you with a software background might know, or engineering background might know about the capability maturity model, how you move claims through levels of maturity, and that's what we're trying to do here. And this dovetails quite nicely, actually, our university's promotion process. So I said that 5 of our staff have been promoted as academics, and that's because our promotion process sort of follows this idea as well. It doesn't call for metrics, it doesn't count beans, or it doesn't rely heavily on quantitative benchmarks. You, in fact, to get promoted, you write an argued case. And so each individual can actually be promoted on different grounds. And that's very useful for us as well. So we've adopted this idea of arguing that our group, our platform is very useful and provides support in this sort of argued case way. And then finally, something else we're trying to do in this comes down to complexity. We don't want to oversimplify what we're doing and reduce it to a series of numbers, which will then lead to driving weird and perverse behaviour and emergent behaviours we don't want. We're trying to use evaluation as a developmental aid and not as an audit function. So what does that mean? It means we don't produce an end-of-year report that's saying, yep, we've completed these things, tick. So, and this is the way that a lot of the projects are done in the university, and I'm sure in nearly every organisation, large organisation, there's some goals at the start. You go off and do the project, and then you tick off the goals at the end. And so you're auditing that the project achieve the goals it was set out to achieve. But this is a very fluid and evolving workforce. So rather than this sort of audit function of box ticking, we're trying to use this idea of examining these claims and making these claims more mature as a developmental process. And this fits in with the literature, the modern literature on evaluation, using evaluation to help develop an initiative rather than just audit it at the end. And again, this is a work in progress. I don't think we've quite got this nailed down yet, but we're certainly working towards it. So to wrap up, we wanted to create this workforce that was technically excellent, but also would translate between disciplines, including between computing and research, but also between other research disciplines. Could help navigate our large and complex university. So as a result, MDAP was created. It's an academic unit. We had 2 stages of recruitment. We did an internal round and an external. It's now operated very successfully for 3 years by any metrics, I think. And perhaps the best one is that we survived COVID, survived the millions and millions of dollars lost of revenue from international students that the university suffered. And then finally, we think carefully about evaluation and embrace complexity, uncertainty, and avoid reducing our enterprise to metrics. That's it.
Okay, Andrew, thanks a lot for your interesting talk and so for sharing your research organization experience. And dear colleagues, it's time for question. So please raise your hands or write in chat. So do we have some questions right now? Okay. Oh, that was my example of raising the hands. So okay, I do have some questions. I think it would be wise to start with them. So Andrew, you mentioned that one of the most important goals of the research data specialist is to support the cross-disciplinary projects. Okay, so could you please give some examples of these cross-disciplinary projects, and also could you please characterize the most important difficulties on the way to collaborate people from these different domains, because it's right the topic of this conference. It's very important. Okay.
Yeah, and so I think there's a few examples. The first one that springs to mind is with the law faculty. So the law faculty had I guess it was a known unknown. They knew that automatic text processing and natural language processing things existed, but they didn't really know how or what. And I think they came to us perhaps with sentiment analysis is something that you read about a lot if you Google natural language processing and law, you come up with sentiment analysis. And so that was the starting point, but we quickly realized as we were dealing with them that their needs were complicated. So some of you can do sentiment analysis on tweets or whatever, right? That's fine. But legal documents have a particular structure, they have a particular style. And so we pulled in, we went to the computer science department and said, hey, we've got this problem over in law. Can you help us out with some novel algorithms? And the most, unsurprisingly, perhaps the most difficult problem there is the translation problem, right? So the NLP people want to talk in models and inputs and outputs, and the law people want to talk about judgments and cases and other things like this. So I think this is where our staff play a very important role. One of our staff members has a computer science degree, but also did a law degree, right? So he knew both languages and he could translate and gently take each of the disciplines on a journey towards each other. And of course, you need the people on both sides have to be receptive as well. But that's by far the biggest challenge, is just the jargon. You know, as we know, we all use jargon to shortcut in our home disciplines, and we forget that often that no one else has an idea what we're talking about. Another good example perhaps was between, there's a group of stone things in Laos. It's called the Plain of Jars. So it's this big archaeology site with these old giant stone structures in them, and no one really knows what it's for or what it's all about. But so the archaeologists were, collecting lots of data. But when we brought in the drone experts, I guess, right? People who can fly over the top and with LiDAR and do sophisticated 3D modeling and 3D analysis from drone data. That again made a sort of a step change in the research direction, changed it to a cross-disciplinary project. Yeah, without a doubt, it's the language, the translation function.
Okay, so we have a question in our chat, a question by Andrei Fionov. So he's asking, so could you please explain some maybe procedure on how you take fundings from corporations and organize projects of mutual interest?
Yeah, so all of our projects are by application. So I guess we put out a call for applications, and then we assess those applications. So at the moment, we insist that there's a university academic involved. So one of the projects we have at the moment is with the City of Melbourne. So that's an external organisation who, as part of their functioning, they're trying to meet the Sustainable Development Goals of the United Nations. So there's a list of, is it 12, 16, 14 goals, and that they said they were going to meet, but they didn't know how to collect the data. They've got all sorts of different data sets from this about the city, but they didn't know how to use that data to see if they were meeting their Sustainable Development Goals. So the academic involved there is actually in the architecture faculty. He applied, and we agreed to take part. The first interactions are free in some sense, i.e. they're cross-subsidised by the university. But after that initial interaction, we then charge sort of consulting rates to external people to continue on. So I guess, let me just reread the question. Did that answer the question? Yeah, so the corporations have to apply through an academic in the university. So really the academic is applying on their behalf. And then we centrally fund the project for a short time, 3 months. And then if they're happy, which of course they are because our staff are wonderful, then they pay more as sort of an external consulting. The mutual interest is that's balanced by the senior committee, a committee of senior academics, professors that review the projects and sort of ensure that they're strategically aligned with the university. So the City of Melbourne, the University of Melbourne, of course, works very closely with the City of Melbourne. So that's a good example. Perhaps if Boeing or Lockheed Martin come in with a weapons project or something, right, then it would not be so strategically aligned, and depending how it was pitched.
Okay, thank you. Do we have some more hands raised? Okay, in this case, I can keep asking. So, so my second question is that at least you mentioned that fair data is important. So I can continue my question in this direction. So could you please characterize the ways of following the open science ideas in your research, and maybe also applying some research infrastructures to publish your data, results, programs, and so on to support reuse of your results in the outer society?
Mm. I'd love to answer this question saying yes, we've solved that problem, but we haven't. But I think the institution, the university supports the publication of data through so things like data and code and the like through Figshare. So it's an external product, but that's supported by the university and through the library, I guess. So the code and the data is supported, can be published, and you get a DOI, etc. So it becomes real in some sense. I think many of the collaborations, I mentioned Git a few times and how torturous it is, but it's used quite a lot by a lot of people. So a lot of the data and code is published on Git, and the university runs its own instance of Git, and so again things are published that way. The university has a commitment to open science, but it's a work in progress, right? So I mentioned the DORA Accord and the not using metrics and journal impact factors and all that sort of stuff. There's a long tradition and culture that has to shift, and that's happening. And particularly amongst the younger generation of researchers, early career researchers are very much embracing open science, and some of the old traditional researchers are not. I'm not saying which category I fall into. And so, yeah, we have facilities for it and we're encouraging it, but it's definitely a work in progress.
Sure, thanks a lot. Do we have more questions in chat or hands raised? Okay, no, not yet. So I would like to ask also about other important issue. So what is your policy concerning attracting students in your research? I mean, not only quite comprehensive students like PhD students or masters, but also bachelors. Do you have some policy for attracting some advertising your projects and so on?
Mm. That's a good question. I forgot to mention we haven't really engaged with the undergraduate students all that much, but we do run a very active internship program. So the way we engage with students is through internships. So we have 3 groups of interns for roughly 10 weeks each. And so they're mainly master's students, masters by coursework, who do an internship subject, I guess. So they can go anywhere, but we've been taking in particularly the Masters of Data Science students as interns and putting them on existing projects that we have. That's been very successful, and it gives our academics some supervisory experience. And also the interns themselves have a good experience. And in fact, we just ended up employing one of them now. So it's also a good pipeline for talent as well. But yeah, internships is the way we engage.
Okay, thank you. And I see that we have a question from Alexandra. So please.
Hello, thank you for a very nice talk. I have a question because, well, I should say that first of all, I'm from material science, and we do quite a bit of computational stuff within the material science, but trying to involve into our field the people from math and other fields, we faced an interesting problem that whenever we are engaging somebody from data science, they face tremendous problems of getting into the field. I mean, the background is traditionally such that they have no idea about chemistry and physics at all. Do you have similar problems? How you solve them?
Yeah, I think we cheat a little bit, I think, because we can select the projects we're interested in. So for example, in the recent round, we had 60 applications or 60 projects that applied, but we only really have resources to do maybe 10 or 15. And so they're usually ranked, in addition to being ranked of strategic value, they're also ranked of the ability and the interests of the staff. So we don't have anyone with a PhD in chemistry, for example. So if you came with a materials project, if it was clearly sort of a chemistry/physics kind of knowledge required, then it would be low ranked and we probably wouldn't get to it. So we checked, I think. But having said that, of course, we tried, and we have, the personality of the people involved. They're very curious, they're risk takers, right? So this is, as opposed to perhaps academics in data science. So in addition to our group, there's also the Melbourne Centre for Data Science, which is a group of data science academics, and they're on an academic trajectory in data science. So that's a different kind of person, right? They're not looking to take risks in material science. They're not particularly interested in material science, right? Whereas the team of people we've employed are curious and interested, and so they will invest the time in material science. I think that's what it comes down to, right? Really, to get up to speed, to even begin to talk the language and do something useful, they just have to invest time and read a couple of textbooks, right?
But do you face the problems with, for example, well, one of the troubles of the material science and chemistry is that everything in our field is relative to something. So there's a kind of the relativeness, and there are different scales. So this is a problem which is very difficult to explain for the person who have never any idea in natural sciences at all. So, and it goes back to school. So how you can, do you have any idea how to close the gap when actually the experience is taken back from before the university, which has to be smashed into the level of PhD?
I think it's a very difficult problem. I don't have a magic solution, I'm afraid. I think transferring from similar, I'm just thinking now, if you came to me with this problem and it had to be solved in some sense, I guess the closest we have are the bioinformatics, so cellular biologists and biochemists, right? So at least they have some knowledge of how chemistry works in biology. Maybe they can translate that to chemistry and materials. So that would be my best guess, would be to try and start with someone at least who has some, not orthogonal, but slightly closer direction. But yeah, there's no substitute for someone who's really smart, who's prepared to put in the work, I think.
Thank you.
Okay, thanks a lot. Do we have some more questions? We do have some time, not so much time, but still. Okay. I do not see any hands raised and any questions in the chat. So I think we'll have to thank Andrew again for his impressive talk and for sharing his experience, which is very interesting, I think, for anyone who is organizing research in cross-domain research and cross-academia and industry research, I suppose. So thanks you a lot. And so that's the end of our first session this day. And I welcome all the participants to the next session, who will be at 12:30. So thank you, Andrew, again.
Thank you very much. It's been a pleasure.